So I'm recording this session. If possible, I will try to share. But make sure that you listen live session. Don't depend on recording. Okay, you'll start. What is time? Recording started. Right. So I don't waste much of your time. I will directly enter into the topic. So I discussed about basic types of images. This is a basic understanding you need to have for the entire semester. What are the different types of images are there? Binary image, black and white, grayscale, and previously Amog discussed about Amogena discussed about grayscale transformation. Grayscale transformation in that you have seen 20 to 255 range of shades are there. Right? Don't do anything that you don't know in the Zoom. Some options are enabled for participants also. Next thing, if you see, I also discussed about application. This is very much important question. You can prepare applications of image processing. So in this application of image processing, like agriculture domain, automobiles, industry, medicine, defense, you can write all of these points in detail. So these are very simple points, remember, and very important also, where you use where you will apply the image processing. So these topics also I've discussed in detail, and you can prepare on your own. This is a very general topic you can understand. And coming to I also discussed last topic, one important topic, that is distance measures. If you don't listen my class, I will just give you a brief about this topic once again. Now, this is also asked in two ways. It may be asked like a matrix, like a distance matrix. It can be asked a question like, are distance metrics, different types of distance metrics, they may ask like that question, are different types of distance measures. Okay. Can you hear me right? Distance measures are distance metrics. So remember, answer is same, but the question may be asked in different ways. So I told you very clear, simply manner, like image is a function of x comma y. In the classroom only I explained, and where I have taken three sample pixels. Here in this, like we are taking two sample pixels, P and Q in the particular image. You can see the distribution of pixels in the image, and you can see the x and y axis and function of x comma y in the slide. So you have taken one pixel and another, P is one pixel and Q is another pixel. Like like how we are going to measure the distance between these two pixels. How we are going to measure the distance between these two pixels. I'll just revise what I discussed in the class. These are some properties: symmetry property, identity property, triangular inequality property. You can see pixels are there here, 3 pixels, Q, P, Q and Z coordinates, X comma Y and S comma T, U comma V, like you can see. So this is, I am assuming this is an image. So this is P, you can see 1 pixel, P, X comma Y, pixel coordinates X comma Y, Q, S comma T, and Z U comma V. So P comma Q distance must be greater than or equal to 0. And it is 0 only if P and P is equal to Q. It's very simple. This I explained in the class. If like you can see, just one second, I will use the highlighter if possible. So here you can see that this point is like a pixel P comma P X comma Y, and this is Q S comma T. What is the basic properties of this? Like a distance of P comma Q is equal to Q comma P. The distance between this one and this one, like a P and Q and P are same. So, and this is a one formula you can see distance between, if you take this as like a triangle, if you assume this as like a triangle, like P comma Z is less than or equal to P comma Q plus distance of Q comma Z. It's a very simple properties you can understand just by. And next, I discussed about three types of measures I'm just revising once again. Euclidean distance measure. This is very important for exam. Euclidean distance measure and the city block distance measure and chessboard distance measure. So as if you can see, Euclidean distance measure, the formula is this. dE of P comma Q is equal to x minus s whole square plus y minus t whole square under root of x minus s whole square plus y minus t whole square. And city block distance, as you can see, d4 of P comma Q like a mod x minus s plus y minus t. Okay. And chessboard, as you see, like here, d8 of P comma Q is equal to max x minus s comma y minus t. So these three formulas you have to remember. These are very simple formulas. And distance measure, you have to explain about Euclidean distance. What is Euclidean distance? And what is city block distance? And what is chessboard distance? All these types of distance measures you have to explain along with formula. Whatever the formula is mentioned here. D of P comma Q formula and D4. Okay. See how we can elaborate. We are applying this formula just like maths formula. Formula is given and we are taking coordinates x comma y coordinates 2 comma 2, s comma t coordinates 4 comma 4. Just replacing x with 2 and s with 4 in the formula. You will get the answer. The answer is under root of 8. Euclidean distance measure is under root of 8. Okay. And next thing is, say you understand this. This formula you are simply applying values. This formula is already there, Euclidean distance measure formula, and simply you are applying the values. 2x is in place of x, you are substituting 2. In place of s, you are substituting 4, and similarly y and t also. And you are getting the answer. This is about the Euclidean distance. You can write some theory. Theory is there in the PPT. Okay. And city block distance also same, like formula is given. You have to apply the formula. D4 of P comma Q, x minus s mod x minus s plus y minus t. Simply we are applying the values, same like values. X in place of x you are substituting 2 and s you are substituting 4. And y minus t also. So here why we are saying x minus s means, like for example here you can see P is there here. This is a P here. And what is the distance between this P and Q? I want to find out. First, from this place to this place, it is 1. It is one distance. From this to this, it is number 2. Number of steps you are moving. Number of steps you are moving. This is first step, this is second step. Vertically, you have 2 steps. And this is 1 step, this is another step. Horizontally, you have 2 steps. So 2 steps vertically, as you can see here, and 2 steps horizontally. D4 of P comma Q is equal to 2 plus 2 is equal to 4. This is referred to as Manhattan distance. City block distance is also referred to as Manhattan distance. So instead of writing in values, simply here you can see 0 is there here. This is from actual pixel. And from this, if you move vertically, you will get 1 step ahead. So 1 we have written here, 2 steps ahead, 2 we have written here. And here also, like 0 here I have written 1 and then I have written 2 value. So number of steps from the actual pixel, selected pixel we have mentioned. 0 is the actual pixel here. As you go horizontally, left side and right side, vertically left side and right side, you can see the values accordingly. Okay, the representation of pixel values in city block distance. Similarly, chessboard distance also, like as you can see, formula once again, the formula is simple. What is the other name of city block distance? Anyone? Anyone can answer me? Guys? What is the other name of city block distance? Type in the chat box. Type in the chat box what is the other name of city block distance. Manhattan distance, Satvika. Satvika, okay, right. Very good. So Manhattan distance is the other name of city block distance. Question may be asked like that also. And so here you can see value max of x minus s comma y minus t. In the previous example, if you can see here, you are combining x minus s and plus y minus t. You are adding these two values. You are adding total number of steps. But here you are taking the, if you observe, you are taking the maximum value of x minus s comma. You are not adding these two in the chessboard distance. Maximum value of x minus s comma y minus s. So here you can see p of x comma y. You can see that vertically two steps are there, 2. Horizontally 2 steps are there, 2 here. The max of 2 comma 2 is 2 value. So like this you can observe. Similarly, we have representation of chessboard distance. You can see here the actual pixel is 0. We are assuming 0. From 0 to how much distance it can go. So like that we are representing. So here also, like you can see with the values, like if this is a representation. If you assume that this is a representation in chessboard distance, what is the value? What is the distance of 2 pixels? So here is P is 1 pixel and Q is 1 pixel. How do you find out the distance? So we can find out the distance by using by being able to write the coordinates. Coordinates are 4 comma 2 for P. P means 4 represents the number of rows. So 1, 2, 3, 4. Fourth row. 2 represents column, first, second column. So 4 comma 2. X comma Y is a 4th row, second column. And similarly Q. Q is the first row. You can see the coordinates you are writing, first row and 4th column, 1 comma 4. And just you are writing x max of x minus s comma y minus t. Simply 4 minus 1 comma 2 minus 4. What is the maximum value? What's the maximum value here? Type in the chart box. What is the maximum value? Somebody type something. 3. Okay. Ritika and Sai. Okay. Value is 3. So here, if you can see, substitute the values 4 minus 1. 4 minus 1 is the 3 value. 2 minus 4, mod 2 minus 4 means 2. Max of 3 comma 2 is 3 value. So here, like this, we can find out the different types of distances using different metrics. Different types of distance measures are there. Using these different types, we can find out. Okay. So next, so you can see here substitution max of x minus s comma y minus t, 4 minus 1. Whatever you have done, the answer is here. 4 minus 1 comma 2 minus 4, 3 comma 2 means max. So here max value is 3. We are taking 3 value. And next is how to convert an analog image to digital image. And one of the important topics in this digital image processing is sampling and quantization. Sampling and quantization. This is a very important topic. So how do we understand, why we are converting analog image into a digital image? Why we are converting? So there are 2 types of image categories. One is analog image category, other is digital image. Why we are converting is because the analog image has continuous values and like a digital image has discrete values. Analog image has continuous values. Digital image has continuous value. Sorry, analog image has continuous values and digital image has discrete values. And the storage is also a problem. If you don't convert the analog image to digital image, it is going to have some problems. So we have to convert. We have to convert any analog image into digital image to apply. Even we cannot apply all the digital image processing techniques on analog image. We cannot apply all the image processing techniques, whatever we are discussing on the analog image. We can only apply it on the digital image. So whatever the techniques that are available. So we always prefer to convert analog image to digital image by applying sampling and quantization. And we also refer this analog image sometimes as analog signal. And so here the problem is we cannot apply digital image processing and its techniques on analog signals. And we cannot have the so too much storage to store analog images. They occupy so much amount of storage data. So we are interested in converting analog signal to digital signal, analog image to digital image. Okay. So next, so what is meant by sampling here is sampling. You can see digitization of coordinate values. You can write down if you want. Digitization of coordinate values. Whatever the coordinate values we are having in an analog image. I will give an example in the next slide that we are converting into coordinate values that we are converting. We are digitizing those coordinate values by using a method sampling. And similarly, we are converting amplitude or intensity of the image using quantization. So the conversion of analog to digital involves two processes. One is sampling and other one is quantization. Okay. Sampling and you can see the analog signal is appearing like this as the output. It is having continuous time and continuous amplitude, whereas digital signal is having discrete time and discrete amplitude. Okay, for storage it is very easy. For storage and we can also applying like techniques, image processing techniques we can apply on the digital image only. Okay. So like this, we can perform the like these two processes very important in converting like analog image to digital image. Okay. So you can see one continuous image or one analog image is given, and we are trying to convert that image into digital image. So this has some coordinate values. We are finding out the coordinate values in this analog image, and we are trying to replicate the same in the digital image as well. And even we are observing like intensity like here intensity is very high in this area. Some areas intensity is very high intensity or high brightness pixels. So this we are trying to replicate as it is in the digital image. Okay. We are trying to replicate, we are trying to just create analog digital image based on observing the coordinate values and amplitude or intensity values that are exactly there in the analog image. Like you can see how an analog image looks like here and how digital image looks like after sampling and quantization. Okay. Generally, there is one more concept called histogram. Histogram I will discuss. Histogram generally, you know, in maths, I've studied histogram. What happened? Somebody is naming themselves as X. So histogram, you can see in maths, you have observed bar graphs, something like this. You have a range of values and frequency, and you will draw some chart like this. How many number of pens sold and what are the frequency? This is the basic idea behind the histogram. You have class interval and you have frequency, number of pens sold. So based on this, you are going to create an histogram. Right. So histogram is also one of the important concept here in this. We have respective formulas also, but first you have to understand the theory behind histogram. So what is the theory behind histogram means you can see here in the next coming slide. So this is an image. If you observe that we are trying to represent an image using histogram. Like if you observe a image, like a pixel intensity levels are varying. You can observe all the pixels are not having the same intensity. Yes or no? Am I right? So how many number of white color pixels are there in the image, histogram image? Type in the chat box. How many number of white color pixels are there? Only one person is responding. Everyone participate. Everyone participate. How many number of white pixels are there in the histogram? Don't be proactive. Just I'm asking easy questions. Only two people are responding. Right. Before I end the question, answer should come very fastly. All of you keep your chat box open and type. So four pixels are there. Sorry, four pixels are there. White color pixels in the histogram. So how do we represent? And this 4 pixel intensity, white color intensity is 0. You can see here. White color intensity is 0, representation 0. And grayscale, you can see. Just one second. So grayscale images are black color. You can see how many number of black color pixels are there? How many number of black color pixels? Black color pixels also 4, and gray color pixels. How many number of gray color pixels? So gray color pixels, we are having six gray color, and you can see light color. In light, there is less intensity. You can see the pixel intensity value is 175. You can see this kind of this color, light gray. It is there. So this is a 175 pixel value. You can see, and anyone in the waiting room? Nagaraj. Okay. So here we are trying to represent this image, which is having different colors, like different white colors, black color, gray, light gray. All these things we are trying to represent in a histogram. So the x-axis we are taking number of pixels, and y-axis we are taking pixel intensity values. One pixel is 0, and one pixel value is, some pixel values is 65, some pixel values are 175, some pixel values are 255. So how many number of pixels are there in white color? 0. Like you can see 4, and 65. 65 means like gray color. You can see 6. And similarly, like light gray, you can see it's appearing 175 around. 2 pixels are there. One is top right side, bottom right side. Other one is top left side. One, this one, and this one, like 2 pixels are there. 255, 4 black pixels are there. And you know very clearly that 0 to 255, how a gray scale image falls in intensity. The intensity we are measuring from 0 to 255. So the same image I am converting to different ways. We are distributing the same pixels within the image, but not in random manner. The pixels are same, number of pixels and everything is same, which is like a diagram, a figure. And in these pixels, it is distributed in a different manner. So if you observe that, and if you try to draw the histogram once again, is it same or different? Same histogram, we are going to get a different histogram. Anyone? I'm just randomly distributing the pixels. Same pixels. And are we going to get the same histogram? Sai is responding very nicely, very good Sai. Rule number 582, rule number 582. Okay, only one person actively responding. No, for this question. Same histogram, Ritika, 588. Okay, so here, like, sorry. So, like, so even if you are changing the pixels here in this diagram, even if you are changing the pixels into different places in the same image, you are going to get the same histogram because the pixel intensity values are not changed. Pixel intensity values are not changed, so we are getting the same histogram. So histogram is like simply to understand you are representing image in a graph. Representing image in a graph uh, by taking the number of pixels in one axis and pixel intensity values in other axis. You are trying to create a graph by using that image and by evaluating the number of pixels and pixel intensity, different pixel intensity values, different pixel intensity level. Okay. So you can see here one more diagram, how we are drawing the histogram. For histogram also you have one formula. I will let you know that formula. Just let me give you a brief about histogram. So here there is a gray image, Einstein image, and number of pixel intensities, grayscale fall from 0 to 255. The total number of intensities are 256. And 0 means black. So here you can see that there is some maybe this exact histogram, if you can see, it's not correct with respect to pixel intensity level, but drawing from these intensity levels is exactly accurate. Okay, so here you have to understand exactly a grayscale image consisting of pixel values 256 intensities, and we are going to draw the chart between these two. And just one second, let me go to back color. Correct only. So here 0 means black. What did I say? Did I say anything wrong here? 0 means black and 255 means white. If I say anything wrong, please correct. So black pixel means 0 in grayscale, and white pixel, complete pure white, means 255. So here also we are following the same. Gray image, number of pixel intensities are 256, and black means 0. White means 255. That you have to remember in a grayscale image. And how histogram image of this Einstein image, you can see number of pixels you have drawn 0 to 100, 200 like this, and pixel intensity values also there like this, you can see. So this is how we are going to, because there is a sufficient number of white and black color. So the complete image pixels are distributed. How they are distributed between black and white colors, we can see in the image. It is having sufficient black and white colors. And this gives a clear idea exactly how histogram will change as we are changing the images, or as we are changing the colors of the, black and white in the same image, but I am taking different images. So here I am taking some images which are pure white, having more white pixels, and some image like more black pixels, and some dull image, or an image which is having pixels of all intensity levels. So I am taking different pixels, different images. And guys, are you listening? How many of you are listening? Raise your hand. Amog. I'm not talking anything unnecessary. Make sure that you be attentive. If possible, turn on the video. I think I'm almost right. So be attentive. I am talking only what is important for your subject and exam point of view. So internal and external. So be attentive until I complete. It's a very simple topic. I'm explaining in easy manner. So more black pixels are there in one image, and other image. Okay. More white pixels are there, and dull image is there, and one more image that is having all pixel intensity levels. As you can see, like more black pixels, you can see here the diagram. It is the value. You can see the image here. It's completely left side of the image. Left side completely you can see. 1 second. I will show you, like 1 second with pen. So here this image is completely, this graph histogram is showing the values, histogram values, more histogram values are black. So all the image pixel values are ranging between 0 to 50 only. So that means there is very less white, very less white pixels are there, or very low white is there in the low brightness is there in the image. So here if you see the second image, more white pixels, the histogram falls between 200 to 255 range, 200 to 255 range. And in this, because there are no, are very less number, almost no black pixels are there. Almost no black pixels are there. So you can see difference here. First image is completely the values, pixel intensity values are from 0 to 50, and second image is like you can see histogram values are between 200 to 255. So this is 0 to 50 values are there, and this is 200 to 255 is there. Next, you take any dull image, like it is falling between 100 to 150 image pixel intensity values. So depending on the type of image, you can see the diagram. Histogram is representing what is the pixel intensity values and how many number of pixels are there. So you can know by using the histogram, by creating an histogram. So here, if a pixel is, if a image is having pixels of all intensity values, so it is distributed all over 0 to 255. You can see here. You can see this diagram, the last diagram. So this is distributed between this is distributed between 0 to 230 around. Like this, every image, depending on the number of black pixels it contains, number of white pixels, or whether it is dull image or completely bright image, or it contains all intensity levels. So depending on that, it is going, we are going to create the respective histogram. So first you have to understand that how histogram can be drawn. You have to take two x-axis and y-axis, and one axis you are taking number of pixel, other axis you are taking number of pixel intensity levels. And 0 represents pure black, and 255 represent pure white. So if an image contains more number of white pixels, you can see the complete graph is on the right side. If image contains more number of black pixels, the complete image is on the like you can see completely left side it is there. And if image consisting of all intensity levels, we are going to have all the types of, you can see the graph is like this histogram graph. So how to apply histogram, where to apply and how to apply this histogram? You can see when you, this is a original image, and after image enhancement, you can see the brightness has been improved in this image. Can you see that original image, which is taken in the shadow or which is taken in the dark? Okay. So the person is shouting something and you are converting this image by applying digital image processing techniques or by applying some filters. We are converting this into a bright color image, which is very good and visible to everyone. And if you can draw the histogram for the original image, and if you draw the histogram for the equalized image or converted image, you can see the differentiation. You can see the differentiation between the first original image and equalized image. So here also you can see original image and what is the histogram of the original image, and equalized image and what is the histogram. So like this, we can or create histogram for each and every image. You can create a histogram for each and every image. Okay, and so when it comes to histogram, just one second. Can you see the screen? Histogram screen. Guys, can you see the screen? Screen sharing is on. Like here, histograms, when I discuss, so you just observe that how image. So this is a very simple information about histogram. In mathematical representation, it is there. In the theory, it is given. In the mathematical, in the PPT, I have given in the mathematical form. But in the explanation, I will share this PPT, and I will also share, already shared this mathematical formula. So there is a mathematical formula for histogram. K is a constant that is representing the size of neighborhood. And this you can go through, and you can also write the earlier points I have just now told. What is a histogram and how the histogram change from image to image, like black and white, and pure black pixels are there, white pixels are there, and you can also mention this formula. So if you want me to explain histograms, this topic, and one more pixel adjacency, like number of neighbors are there for the pixel. You can see one pixel is there. This is called 4 neighborhood. The neighboring pixels. This is a 8 neighborhood means you can see 8 neighbors are there for this pixel. So we are taking 2 pixel p comma q and neighborhood. This first image represents in 2.2. This is called these 2 images represents neighborhood and also pixel adjacency. Pixel adjacency also represent 4 neighborhood and 8 neighborhood. 4 neighborhood will be represented like this, and this image also you can see. And 8 neighborhood, you can see 1 pixel is here and 8 neighbors. And this one similar to this one. So what is a pixel adjacency and explaining about histogram mathematical I will explain. And one more is like this properties, what do you call topological properties. Topological properties means what is a region, what is a hole, what is edge, and this mathematical and you study this if you can read the definitions of entropy, acuity. Okay. Read the definitions of entropy and acuity. And basic information I told you, types of images for simple. Noise in the images also. So these topics I will explain tomorrow, same time. Noise in the images and like, histogram, mathematical application, formula, this one is there, no? Mathematical part of histogram and the possible topological properties of this one. Metrics anyway I explained. Metrics, distance metrics I explained, Manhattan distance, Euclidean, I explained. Apart from that, topological properties like pixel adjacency, region, hole, edge. These topics I will explain tomorrow. So meanwhile, you just go through whatever I explained to you, in histogram topic. Hope you got the important questions, whatever I'm explaining, like histograms, topological properties, I'll explain tomorrow, same time. And metrics, distance metrics, I explained today and in the class also. And next, applications of image processing, I already explained applications of image processing. Okay. And definitions, basic definition you can prepare yourself, or I will also, you remind me tomorrow what is the definition of acuity, definition of entropy, and noise in the images also if possible. I will explain tomorrow. What are the topics remaining? I will explain tomorrow for your. And meanwhile, you can prepare what I told you today. Okay, whatever I discussed to you today, and you can also prepare these topics on your own. And but tomorrow, I will try to explain in half an hour or 40 minutes. So your entire first meet preparation will be completed if you follow what I say. So that's all for today. Hello, guys. Can you hear me?
Okay, sir.
Okay. Just go through the topics I've explained today. I will share the same PPT in your group. And if you want to write, you can always prefer to write whatever I explained in the exam. You don't have to write. I don't mind if you are writing something else. I will make sure that whatever you're writing in the exam, I will make sure that I will explain you in the classroom. So if you don't know the answer, if you are not able to prepare from the PPT that I already given, if I don't mention some points, you can always write whatever I explained. You can always prefer to write whatever I explained in the in the classroom or in the discussion or in the Zoom meeting. So I will share the topics I explained in the image group and you can prepare them. And meanwhile, I will tomorrow at the same time, I will explain the remaining topics mathematically, histogram and other points I will explain. Okay. Yes, it is simple for your preparation only. It is a preparation for your mid exam. Well, so you will write everyone, you will write exam very well. Okay. I will share the PPT. So main important question, long questions you have to attempt. Applications, image processing, distance metrics, topological properties. I will explain tomorrow, topological properties and noise in the images, histograms. All these are long questions you have to prepare. And if any topic I have not covered, I will explain, I will cover tomorrow. And if any points also missed, I will explain tomorrow. Okay. Right? Is it clear? Guys, someone will respond. Okay, I will share the PPT. Don't worry. Whatever I discussed in the class and whatever I discussed today, same points you can write in the exam. I will make sure that remaining points also I will make you clear. Then only you can write. Okay, I will share the PPT. Till now, whatever I simple topics, simple concepts I covered, I am going to share that PPT and you can follow from that. And if you want to write extra points, you can write from another PPT also. Okay, thank you. Thank you, guys. Thank you, everyone. And tomorrow at the same time, all of you join me. Is it okay? I'm ending this meeting.
One doubt.